Bismillahirrahmanirrahim. Welcome to the first part of 17th lecture of Statistics and Probability Theory. In previous lecture, we have studied Poisson distribution. Poisson distribution is basically for the rare events, and as we have studied that in the probability mass function of Poisson distribution is P of x as x is the random variable is equal to e raised to power minus lambda into t lambda into t raised to power x whole divided by x factorial, where x is equal to 0, 1, 2 up to so on. So this is the probability mass function of Poisson distribution depending on some specific time or the region of the opportunity. And we have studied that the unique property of Poisson distribution is it has same mean and variance. Its mean is equal to its variance, which is lambda into t. Further, we have studied that whenever we have n very large, as n is the number of trials in binomial distribution, and p, which is the probability of success in binomial distribution, becomes very small, binomial distribution with the random variable x and parameters n and p will become Poisson distribution. Poisson distribution with the random variable, with the same random variable x, and the parameter mu, where mu is the mean of the binomial distribution, which is n into p. So this is the review of the previous lecture. Topic of this lecture is uniform distribution. We will study discrete and continuous as well. So let's consider x is a random variable defined on a sample space of rolling a die. So whenever we roll a die is a six-faced fair die, and it has 6 outcomes: 1, 2, 3, 4, 5, and 6. So this is the sample space of rolling a fair die. Fair die means that each outcome has equally likely chance of occurrence. That is, whatever the chances of the outcome 1 have to occur, the 2 will have the same chances of occurrence. Similarly with 3, 4, 5 and 6. So all possible outcomes are mutually exclusive and equally likely. So let me draw this probability mass function. So let's suppose this is the y-axis and we have probability of occurrence of the particular outcome at the y-axis, and this is x, and x is the possible values of the random variable, and random variable is associated with the outcomes of rolling a die. So whenever we roll a die, we can have possible outcome 1. And what are the chances of the occurrence of 1? As we know the definition of the probability of an event, which is the number of favorable outcomes divided by total number of outcomes. So favorable outcome is 1 and total number of outcomes is 6. So the probability of occurrence is 1 by 6. So let me draw the bar representing the probability of occurrence of the outcome 1. So the other possible outcome is 2. So what are the chances of occurrence of the outcome 2? Again, it is the fair die and the all outcomes are equally likely. So by the definition of the probability of an event, the probability of the occurrence of the outcome 2 is again 1 by 6. So by again drawing the bar for the event or the outcome 2, it will be same as we have drawn for the outcome 1. So the other outcome could be 3. So it will have the same chances of occurrence, which is again 1 by 6. The height of the bar will be same as for the outcome 1 and 2. Similarly for 3. Similarly we will draw for 4, 5 and 6. As all possible outcomes are equally likely, so each outcome has same chances of occurrence. So next will be 5. And the next will be 6. So these are all possible outcomes of the random variable x, and this is the graph for the probability mass function of rolling a fair die. So this is the scenario, and as you can see that height of each bar is same. So this is discrete uniform distribution, and each outcome is equally likely. So this is legitimate probability distribution. So you can say this is discrete uniform distribution. Now consider that the die is no longer fair. What does it mean? Let's suppose that you have a die and as the die has the faces, it could have the face with the outcome 1. This represents 1, and you could also have the outcome with the face representing 2 dots, which is representing this 2, or you can have the face which can turn up with 3. So let's suppose that something happened and one of the dot is erased from the face containing 3 dots. Now what happened here? The two faces will have the similar outcome. So what will happen? Now we will draw the probability mass function for this particular scenario. Keep in mind that the die is no longer fair now. Why? Because two of the faces have similar outcomes, and if two of the faces have similar outcomes, then the chance of occurrence of that particular outcome will increase. And if we say that our die is fair, then each and every possible outcome should have equally likely chances of occurrence. Now, let me draw the probability mass function for this particular situation. Now, what we are saying that these two have the two faces, that if you have 6 faces on a die, 2 of the faces contains the 2 dots. Now, the chances of occurrence of 2 will increase. It will become 2 by 6. So, it will be 2 by 6. So, here will be 2 by 6. So the probability of occurrence of the outcome 1 will be same. It is 1 by 6, but the chances of the outcome 2 will increase. It will be 2 by 6. So the height of the bar will increase to 2 by 6. Now, what are the chances of the outcome 3? As one of the dot is removed from here, so there is no chance of occurrence of the outcome 3 because none of the face have 3 dots. So it has 0 probability or 0 chances of occurrence. Rest will remain the same. So now this is the probability mass function for this particular scenario for this particular unfair die, but this is no longer uniform. For the case of discrete uniform distribution, each possible outcome should have equally likely chances of occurrence. So let me explain some introduction to you for the discrete uniform distribution. Uniform distribution is defined as the type of probability distribution where all outcomes have equal chances or are equally likely to happen and can be split into a continuous and discrete probability distribution. These are normally plotted as horizontal lines. If the random variable x assumes the values x1, x2 up to some particular value xk with equal probabilities, then the discrete uniform distribution is given by f of x k, where it is equal to 1 by k. And the mean and variance of uniform probability distribution function is mu is equal to sum of all possible values of the random variables divided by 1 by k, as we have k number of values, and variance is equal to sum is into xi minus mu, where mu is equal to this particular case whole square divided by k. So this is the mean and variance of the discrete uniform distribution. So this is the example which we have explained in the first slide. Rolling a die and x is the number of rods, and the distribution has the form f of x is equal to 1 by k, as we are saying that there are 6 possible outcomes. So k will be 6, it will be 1 by 6 for x is equal to 1, 2 till 6. This is the probability function, and this is the distribution function or cumulative distribution function, which is x by 6 for x is equal to 1, 2, 6. And the mean and the variance of the discrete uniform distribution, as we know that it is sum of all possible values divided by total number of values. It is all possible values of a random variable is 1 plus 2 plus 3 plus 4 plus 5 and plus 6, as there are 1 to 6 possible outcomes in rolling a die. Total number of outcomes is 6. 3.5, which is 3.5, and variance is, as it is equal to 1 by k x1 minus mu whole square. You can open this summation in this way, plus x2 minus mu whole square plus up to so on. It would be equal to x k minus mu whole square. So in this case, we have mu is equal to 3.5. The very first value of the random variable is 1. So 1 minus 3.5 whole square plus 2 minus 3.5 whole square up to so on. 6 minus 3.5 whole square whole divided by 6. So this is the variance of the discrete uniform distribution.